Welcome on our YouTube channels. We will today start with the new chapter, the surface chemistry. In these chapters, we will see only about the surface phenomena.
In
Let's
this
start.
chapter, we'll see some basic terms. The first basic terms is adsorptions. What is adsorptions? The accumulation of molecular species at surface rather than in the bulk than in the bulk. It means the accumulations of molecular species at surface rather than in the bulk we will understand with the help of some examples. The first example is blackboard and white chalks. We write with white chalk on board. We see some powder, white powder, remaining on blackboard. This white powder is covering only outer surface of the blackboard but doesn't go into the board means it doesn't go into the bulk of the board. It's only cover outer surface of the blackboard. In this case, we have in adsorptions we have two terms: adsorbate adsorbate and adsorbent. What is adsorbate? Adsorbate, it is a substance. It is a substance which is being adsorbed on the surface of adsorbent means this is a substance. It is substance which is being absorbed on the surface of a adsorbent. In this case, chalk is a adsorbate. What is adsorbent? It is a substance present in the bulk on the surface of which being adsorptions is taking place. Means in adsorbate, it is a substance present in a bulk on the surface of which being adsorbate is adsorptions is taking place. Means in this case, blackboard is adsorbent meant adsorbate adsorbent is taking place on the adsorbent means white chalk is taking place on the outer surface of the adsorbent. If we see the sentence of adsorbate, I'm writing here, it is a substance which is being adsorbed on the surface of adsorbent. And what is adsorbate? Bent. Adsorbent. It is a substance present in a bulk on the surface of which is adsorption is taking place. We see second example is wooden block. Wooden block and red color solutions. We have red color solutions. We have red color solution. If we put this red color solutions on the wooden block, it will adsorb on the outer surface, only outer surface of the wooden block, but doesn't go into the bulk, means it doesn't go inside the wooden block. It's only cover the outer surface area of the wooden block. In this case, red color solutions is a adsorbate and wooden block is a adsorbent. Adsorbate, it is a substance which is being adsorbed on the surface of adsorbent. In this case, red color solutions it's adsorbed on the wooden block. It's adsorbed on the wooden block. What is adsorbent? In this case, wooden block adsorbent, it is a substance present in the bulk. The second term is desorptions. It is the process of removing an adsorbed substance from a surface on which it is adsorbed. Means it is the process of removing an adsorbed substance from a surface on which it is adsorbed. In simple words, we can say removal of adsorbate from adsorbent. We can say in simple words, removable of adsorbate from adsorbent. It is the reverse process of adsorptions. If we see we can erase blackboard with the help of dusters. The white powder will remain on the dusters, and if we clean these dusters, the white powder will be go outside of the dusters. It means this is the one type of example of desorption.
See the difference between adsorptions and absorptions. There is small difference between the adsorptions and absorption. Is spelling is add d and here is b. Okay, but this small difference, but if you see the concept is fully different, and if this is the most important topic in 12 board exam point of view. If we see the adsorptions, what is adsorptions? Okay, we see early in the lectures, adsorption, the accumulations of molecular species at surface rather than in the bulk. Okay, this is the adsorptions. We will see the first difference is higher concentrations of gas or liquid on the surface And if we see absorptions, see particle of gas or liquid uniformly distributed throughout the body throughout the body. It means if we see the example of adsorptions, then if we have dry wooden block, if we put red color solutions in red color solutions on this block, the red color solutions will only cover the outer surface of the wooden block. It doesn't go into the bulk of the wooden block. It only covers the outer surface area of the wooden block. In case of absorptions, we take sponge. Okay, we take one sponge, and if we put sponge, this is the sponge, if we put red color solutions on the sponge, this red color solution will be absorbed or full on the whole body, throughout the whole body of the sponge, and the size of the sponge will be more than compared to early. Means particle of liquid uniformly distributed throughout the body. This is the absorptions. Second difference between adsorptions and absorption is absorption is a surface phenomenon and absorptions is a bulk phenomena. We see in this example, this is the surface only cover the outer surface of the wooden block. That is surface phenomena. Adsorption is surface phenomena. In this case, sponge, we take one sponge and red color solutions. If we put red color solutions on the sponge, these red color solutions will go into the bulk of the sponge. Absorption is a bulk phenomena. Third difference between adsorption and absorption is adsorption is a rapid in beginning and its rate slowly decreases. If we say absorptions occurs uniformly, means same rate, means form rate, means same speed, means in adsorptions we see this is the outer surface area of the wooden block. This area will decrease when solutions will get cover this area. The area will decrease, and that's why also rate is decrease. In this sponge, solution will go into the bulk of that sponge. That's why the rate of absorption is same at from starting to end point. Fourth difference is adsorption is a fast process and adsorption is slow process. This four differences between adsorption and absorptions. This is the one most important concept according to 12 board exam point of view. The next term is sorption. Sorption. Sorptions. What is sorptions? Adsorptions. Adsorptions and absorptions take place simultaneously it's called sorption. Means at the same time the adsorptions and also absorptions take place. It's called sorption. If we see that one example is towel in water. Example is towel in water. This is towel. If we put this towel into the water, this towel will absorb water, and also water will be adsorbed on the surface of the outer surface of the towel, and also goes into the bulk of these waters. This is why this process is called sorption. One of the example is towel in water. Example of sorption. The next term is occultations. Next term is occultations. Next term is occultations. What is occultations? It is a special case. It is a special case in adsorptions. When gas is adsorbed, when the gas is adsorbed on surface of solid. It is a special case in adsorptions when gas is adsorbed on surface of solids. It is a one type of adsorptions. Occultation is a special case in adsorptions. Air adsorbate is gas, and adsorbent is solid. If we give one example of occultation is silica gel. Example is silica gel and air. When when the air becomes dry in presence of silica cells, means when silica cells, when air comes around to silica cell, air will absorb on the surface of silica cells, adsorb on the surface of silica. Next, we see the mechanisms of adsorptions. Why adsorption arises? Adsorption arises due fact to the fact that the surface phase particle at adsorbent adsorbent are not in the same environment as in the particle in bulk. The particle in bulk. Adsorption arises due to the fact that the surface particle at adsorbent are not in the same environment as in the particle in the bulk.
We will see the why adsorption occurs. We will see with the help of
Inside the
diagrams.
bulk.
If we see, this is the diagram. This is the one diagram. Okay, this is the one diagrams. Okay, and this is the one diagrams. This is the one diagram. Okay, this is the particle at closer to surface. This is the one particle. This is the one particle. This is the one particle, and this is the one particle. The particle. Particle and it's the particles. Okay, like just like that, there is also particle. It's the particles. If we see this is the boundary, this is the outer surface, this is the green color, this is the outer surface of the object. Okay, if we see if we see these we see these particles, these pink color particles are very closer to outer surface of the object, and this blue color, these particles, remaining particle, this is the bulk particles, means inside the particles. Okay, if we see bulk particles bulk particle in this diagram, and we'll see surface particle in these diagrams. If we see the bulk particles, this is the bulk particles, blue color particles are particles in bulk, means this is the inside the particles, inside the object, inside the outer surface. Okay, if we see these particles, this particle will be move will be move by this particle like this.
this particle will be forced to move. This is the bulk particle. This particle will be pull this particle in this side. This particle will be also pulling this particle in this side, and this particle will also pull this particle in this directions, and this particle is also pull in our directions like this. If we see the net force, if we see this particle is balanced from all directions, all four directions, therefore the there is force is balance, force is balance in case of bulk particle, in case of bulk particles, and therefore net force, the F, net force is equal to 0 in bulk particles. But in case of surface particles, if we see, this is the surface particles coloring pink, this is the surface particles, this is the surface particle, this is the surface particles. If we see these surface particles, if we see this, we consider these particles the surface particles, we'll see about these particles. If we see this particle will pull this particle in our this directions, this particle will also pull in these directions, but this particle is also pulling this particle, but there is no one to pull in upward directions. Okay, means no one will pull in these directions, in upward directions, in upward directions. Okay, there has net force, net force of surface particle is not equal to 0. This is more important. Net force of surface particle is not 0. That's why in surface particles there was unbalanced residual force, residual force. Because of this unbalanced residual force, because of this force, adsorptions take place to make to make to make net force equal to 0. To make net force is equal to 0, adsorptions occurs. Net force 0, adsorption occurs. If we see in these particles, bulk particles, this particle will pull in all four directions equally. But if we see the surface particle, there is no one to pull in these directions, no one pull to these directions. This was, there is an unbalanced residual force. To make this unbalanced residual force unbalanced residual force, because of this force, adsorptions take place to make this unbalanced force to make balance. When adsorptions occurs, net force is become zero. That's why these adsorptions take place at the surface at the surface of the object.